So I'm sorry about the video, the microphone. The microphone I've got to use is on the computer. Normally I'd have it here on my headphones, which is not working at the moment. So technology, how good. So the assignment, if you haven't already, hopefully you would have clicked that on there already. Remember that if you want to talk to me, because you're all muted, you'll need to go into the chat. How good. Just checking to see if I can mute you. Oh, okay, I can. Cool. All right, so let's do this properly. All right, so remember that you write your questions here if you want to let me want to interrupt me for any reason. I need to ask me a question, just jump in the chat and I'll keep having a look at this one. This is going to be pretty quick, this one. I'm just going to show you how this will work and a couple of things. So obviously you guys know that you can do it. I'm just going to write some stuff as well. So you're about to get a picture of the roof. There we go. So I'm going to go through the notes. You should have your trig booklets. If you don't have your trig booklet, sucks for you. But you should have your trig booklet ready to go. We're going to go through just the very start of it. Okay, so great. I'm going to start sharing my screen with you. I'm going to record this, by the way. That way I can put it up somewhere for you. I'm going to start recording, showing you my screen, and then I will. Yeah, we'll just get going. I just want to go through a couple of things, tell you how it's going to work. Put it over here. So, all right, so you should now be able to see my screen. On here, I've got just the trigonometry booklet. Okay. A couple of things I want to show you. So, the first thing we're going to do, I want you to remember, so what I'd like you to do, please, is have your booklets ready to go. We're just going to work through it today. This should be a very quick one, and we're going to upload some work into the assignment, and I'm going to show you where you ask me questions. So let's do that first. For people who would like to ask questions, where we're going to go is in the collaboration space, and I'm going to create a tab that's today's date, and then we'll just go there. If you want to ask a question, just make your own page and just put the question in the title here. So if you want to ask question 5D or whatever, you just put question 5D there. You please take a screenshot, put the question there, and then I can either talk to everybody and go through it, or if you know how to do it, you can just turn the volume down and keep going with your work. So that's how we'll answer more in-depth questions. But for today, what I want to do is show you what we'll go through these trig notes together, essentially. And just get started on the first exercise of trigonometry. So are there any questions before I get started on that? If there are, just chuck them in the chat. Ash, you can't put your hand up. No? Oh gosh, I can get almost every single person on the screen. Sure, see that, Ash. That's fine. Ash, they're not doing attendance today. So Ash, we're not doing attendance today, so you're good. Yeah, that's not how you spell yes. So, good question. Alrighty, let's go. So, the first thing I want you to have a look at is the contents page. So, if you have a look through trigonometry itself, the contents page. So, we're just going to go through angular measure today. In fact, we're only going to go through 1.1, 1.2. Then you can do some questions. But you can see here we've got quite a bit. There's a bit of crossover. For instance, angles of any magnitude is what we did in year 10, so you can have a fair bit of that. Non-right angle involved. And then we've got some further trigonometry. Now, if you have a quick look at the syllabus dot points, most of trigonometry is 2 unit, but then there's also extension 1, and that's the further trigonometric identities. That's these ones here. Now, not all of those are going to make super sense at the moment, but just keep in mind that this topic has both 2 unit and 3 unit elements to it, which means when it comes to assessment tasks, there are certain parts in the trig booklet that you can't be tested on in 2 unit, but then obviously in 3 unit you can be. This one in particular, these equation solving techniques down here, very important for 3 unit and really important for students heading up into 4 unit. So I want to go through angular measure today. Again, just so we're clear about questions, if you need me to stop and you've got a question in the middle of something, put it into the chat. Okay, I'll keep looking there. Just a question, I'll stop for a second. Follow on, obviously, if you can with the screen, and then if you actually, you know that I can actually see you, right? Very good. Very good. This is really going to work. Okay, so let's go through this really quickly. So we've got degrees, minutes, seconds. There is a degrees, minutes, seconds button on your calculator. This is one. It's pretty straightforward. Essentially, you need to go between the two. It's written like this. So you've got 134 degrees, 45 minutes, and 13 seconds. Okay. Just keep in mind that when you're rounding, it's 30 seconds in a degree and 30. So 30 minutes in a degree and 30 seconds in a minute. So this would round up to 135 because that's above 30, and this one would round down to 89. Pretty easy. When you go to the nearest minute, though, this one stays the same. So it's 134 degrees and 45 minutes, whereas this one, 43, is over that. So it would be 89 degrees and 22 minutes. Converting them to decimals is really just an exercise in using a calculator. So if you want to enter something in degrees and minutes, you just got to use the degrees and minutes button several times. So just bear with me while the pen doesn't work again. So if I want to enter in 117 degrees, there we go. Okay. So we've got 100. Why? It's good. It's good. It's so good. Oh yeah, that works. Stop it. Mr. Greasley may have solved the world's problems there. Okay, good. So if you want to enter in 117 degrees, you hit that button there, which is this button. Okay, and then you hit 17 and you do it again, and then you hit the 48, and that's enough. Okay, and if you just press equals, it'll just tell you what it is, and then you can use, whoa, go away. And then you can use shift, this button, and it will change between the two. So if you just want to make sure you can do that, so grab 117 degrees, 17 minutes and 48 seconds, hit equals, and then make sure you can change it back. It's just shifting that button again, and you should get 117 degrees. 0.2, we need 3 decimal places, 296 recurring. So 117.297. Everybody can do that? Nobody can't do that? Can you please write there's only 30 minutes in degree? I don't want to do that because that's not right. 60 minutes in degree. You just round up or down. So make sure you can do that. If you can't do that, let me know. It's even easier when you go the other way. You enter 72.326, and then you hit the degree button, so once, so that whole thing is considered degrees, equals, and then hit the shift, this button again, and it should give you the in degrees, minutes, seconds. So just try that again, 72.326 degrees equals, and actually mine just puts it straight in there automatically. I don't even have to use the shift one, but you may have to. And it's 72 degrees, 19 minutes, and 33.6 seconds. Yeah, you said 30. No. I said that. I said there's 30 seconds in a thing. Oh, Karen, what are you showing me in your calculator? I said that, did I? Oh, sorry. No, there's not 30 seconds. There's definitely 60. My apologies. 30 is the rounding up, rounding down. Yeah. Is there anybody, if there's, we can't make decimals into minutes. So hang on a second. All right. So you can see mine? it's going to be backwards. Okay, so I just enter in the, so here, 72.326, like that, since it's backwards. So you do that, and then you hit the degrees button. So then it'll look like that. Then, if you hit equals, mine actually just converts it straight into it. Yeah? Yeah, you've got to click equal first, though. Oh, Tom Finlay, good point. So when you do, Tom's just mentioned in the previous question, at 117 degrees, right there, and then we had 17 minutes. Like that. If you need to enter in seconds, 48, you need to hit that button again. So it looks like that. Yeah. And then you hit equals. And that one will put it into degrees, minutes, seconds. And if you want to convert it there, it's shift and the same button. And then mine puts it in decimals. Just did. Actually, literally just did. Yeah. So enter it in like this. Yep. Right. 117 degree button, 17 degree button, 48 degree button. Hit equals, and then hit shift, and then degrees. And it'll convert it for you. Right. Okay. So let's keep going. So we know how to convert those. Obviously, we need to be able to use both of those. It's not a super big deal to make sure that it's always in one of them, but and just, I'm just going to take my headphones out. Yeah, it's not a big deal to be, like, most of the time it doesn't really matter which one it is, but the reality is they can give you those things in any form. So you need to be able to have, you need to be able to go between the two forms. So this is the important bit. So this is radian measure. So, oh, I haven't got you on screen share yet. My apologies. There we go. Great, okay, so radian measure. So, I mean, the idea of 360 degrees was essentially just a construct that we made. We just made it. There's no real reason to use 360. You know, a lot of people say it's sort of number of days in a year approximately, and so that's fine. But actually, it's still just pretty arbitrary. Okay, there's no real reason for using the 360. Radian, however, is an actual measurement of curvature. Like, it's an actual rotation. And here's how we get it. Okay, so we define it like this. The definition of a radian. So this is 1 radian. A radian is defined to be the angle subtended at the center of a circle. So subtended just means created here by an arc which has a radius equal to the circle, right? So in other words, this length, this arc length, is the same as this. So we just used 1, right, in this particular case. So if the angle is subtended there and they're the same, then this rotation here will be 1 radian. So we use this little symbol for radians, like a little superscript C. But to be honest, most things are considered to be in radians unless you say otherwise, so you don't really need that. Okay, this is the really interesting part. It brings back in pi in terms of angular measurement. So you can see here that we have a semicircle, so a semicircle is going to be this. Right, we know that's 180 degrees, okay, but we want to know what that angle is in radians. So what I'm going to do is make it a radius of x here. Sorry, not x, we're going to make it 1. 1 here. And remember, we want this length, right, the circumference of that one. So we know the circumference is twinkle, twinkle, little star. Circumference equals 2 pi r. So in this case, the circumference would be 2 pi. But this is a semicircle, so we're going to divide it by 2. So it's just pi. So this length will be pi units. And so by the radian measure there, an angle of 180 degrees is going to be equal pi radians. Okay, and this is how, this is going to form the basis for essentially every other angle that we ever measure. We're going to be measured in this one. So essentially what we're saying is that this is 1 radian, But 1 radian itself, like as in 1 radian, here like this, not a super useful measurement. So what we want to do is in angles that we know, and one of the most common angles obviously is 180 degrees. So we did the semicircle, and all we did was we work out the arc length here, the arc length like this, and we divide it by the radius there, and then we end up with 180 degrees. So a semicircle is this in degrees is the same as pi radians. So that's a conversion that we're going to have. They're essentially measuring the same thing, but that's how we convert between the two. We're going to have 180 degrees is equal to pi radians. And so we're going to try and find every other angle that we ever give. We're going to try and convert it so that it is in radians. And this is how you do it, right? You use this, okay? This bit here. And so converting between the two is going to become something that you need to do very often, right? Hopefully we'll just skip degrees completely. But let's say, for instance, you have an angle that is in x degrees, like this. This is the, x degrees is how much we have. What we want is that in radians. Well, if pi radians equals 180 degrees, then it's 1 degree is equal to pi over 180 radians. So x degrees is going to be equal to pi over 180 times whatever that value is in radians. So the conversion is essentially this bit here, multiplying by pi on 180. Yeah, sorry, Asher, I missed your question, and thank you, Paul, that's perfect. The radius was just 1. So this conversion is what we're going to do, and it means we get some really nice angles for some very, very common ones, right? Oh, we'll summarize it here. So to convert degrees to radians, we simply multiply by pi over 180, and we do the inverse to go the other way. We multiply by 180 over pi. I must admit, this one's not super common. We don't often have radians and then need degrees, but the other one is very, very common. And so we're going to be doing that a fair bit. So before we go on to this next bit, these are some really common angles. And so essentially these will hopefully become synonymous with the radian measure as opposed to the angular measure. 30, 45, 60, 90, 180, and 360. Does anybody know why we're picking these particular ones? There's something pretty special about these angles. Just chuck it up in the chat if you know. Yeah, Ashley, very nice. Sine cos tan, Tom Finlay, smashing. So these are the ones that we have the nice little exact values for, okay? So the exact values we have are for these angles here, which is great. We want the radian measure for those as well. And the radian measure is pretty straightforward. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. Then we have pi over 2, pi, and 2 pi. So the fractions end up being quite nice for those. And you can use them there. Obviously, they're the really nice ones. If you need 250 degrees in radian measure, can I suggest, oh, this is great. This is a perfect example. So if we need 250 degrees, okay, we're going to multiply by pi over 180. I would keep that as a fraction. This is radians. So then you have 25 pi over 18, and then maybe see if you can simplify that one. In a particular case, you can't. I would leave it like this, okay, as a fraction, multiple of pi. Just very, very easy to do then, okay? You can, however, give it as a decimal. And if you give it as a decimal, you would simply do 25 times pi, calculator, and then divide it by 18. And so you, right, and then hit the SD button. So I'm just going to stop sharing my screen for a second. So it would look like that. Right, that's like that is how many radians it is, 4.363, blah, 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 blah. But that obviously is super messy, and it ends up being much, much nicer if you express it as a fraction of pi. Alfie, how do I get those? Just as the fractions of 180, mate. And I'll quickly show you. Just as these ones here, just very quickly, 30 degrees is 1/6 of 180. But 180 degrees is pi, so it's 1/6 of pi. So it's just pi over 6. Or you can do it our long way where you do the actual conversions. It's up to you. But we do those quite often. So it's better to just remember those. You'll just do them all the time. For the next ones here, again, I would do the same deal. 120 is 120 out of 180 times pi. And then simplify the fraction. So end up with 2/3 of pi. Or 2 pi over 3. 300 is a nice one. That's you can think about it a couple of different ways. I mean, you can do 300 over 180 times pi, which ends up in 5 pi over 6. But actually, the way that I like to think of that is that 300 is 5 times 60, and 60 is pi over 6. So it's just going to be 5 pi over 6. 472 is a bit awful, but you can just do 472 over 180 times pi. So when you do that one, if you just simplify the fraction 472, you get 118 over 45 pi. Now, the thing you got to remember here, 472 is the same angle as 472 minus 360. So that's what, 112. Which means down in Radian town, what you can do, remember the reason those are the same is because they have a difference of 360 degrees. So if you want to find it with radians, you can have a difference of 2 pi. So if I subtract 2 pi from that, I end up with 28 pi over 45. And those two angles are exactly the same. Not just the same value, but exactly the same, as if you end up in the exact same place. Ooh. 300 over 5 over 3. Yes, thank you. 5 over 3. It's just Mr. not being able to do maths. How did you get this exactly? So you're going to keep a fraction with pi? Yes. So going back to Alfie's question, yes, I recommend keeping the fraction with pi. Where did you get the 6 from? Asher, Alfie, and Asher, Alfie. Yeah, I think the 6 was me not being able to do maths. It should definitely be 3. Tristan did this in France, so he's going to be le prepared. Fantastic. So for the next one here, it's even easier to take into angles. Like, I mean, you can just remember pi on 3 here. It's 180 divided by 3, so it's 60 degrees. But if you don't remember those, it's still pretty easy. This case, this is 5 times 45, so it's 225. And the last one here is 8 times 180 over 9, which is 160 degrees. Yeah, meeting closes in 3 minutes. So what I'm going to do is stop this one. It's probably enough for us today anyway. I'll put this one up here so you can have a bit of a reference to it. Tomorrow's double period, we're going to be doing something very, very similar, except I'll be also getting you to do some questions. So get pumped for that one. I'm going to set up all that stuff now, so it should be ready for you, but obviously I won't actually be online until our classes are there. So in the last couple of minutes, does anybody have any questions about anything we've gone through before this? Question, Alfie. I have a question for you, Alfie. Why are you wearing a hat inside? Yes, Ashley, how far away are the stars? Excellent question. I won't be answering that. 1.9. Oh, so 1.9 here, you're essentially just replacing pi with 180 degrees because pi is 180 degrees. So this question is not really. Here, you just say, well, pi over 3 in radians is the same as a 180 degrees on 3 in degrees. So that's 60 degrees. So that's converting it into there. And then 1.8c. Oh, so this is an important bit. So we might just spend the last couple of minutes on this one. So 472 degrees is bigger than a revolution, which means we don't have to use 472 degrees. We can use an angle smaller than that. And it turns out the angle smaller than that is 112 degrees. So these two angles are exactly the same. If you remember it through rotations, 112 degrees is about here. 472 degrees is here, right? It has that extra bit of rotation, but is exactly the same. So in degrees, that's easy. We can plus or minus 360 whenever we want, right? There's no problems. But in radian measure, we can't add and subtract 360 because we're not using degrees. What we add and subtract is a rotation in radians, which is 2 pi. So let's say, for instance, I didn't change the degrees to 112. I changed it to radians first, so I divide by 180 and times by pi, and then I simplified the fraction, 118 on 45 pi. So that is, we can say, that time, don't rush. Okay, don't freak out.